All right, in this video, we're going to use our properties and our understanding of logarithms and exponential functions to solve some problems that involve logarithms. And we'll start here with the one where we have a log base 5 of 8 minus 2b is equal to a log base 5 of negative 3b plus 6. Well, like we have solved some other problems before, we're going to use the same technique that we have done for rational functions and exponential functions, where if we have a function, in this case log base 5, applied to my entire left side, and I say that has to equal a log base 5 applied to the entire right-hand side, we can set the insides equal, and we can solve for the variable. So 8 minus 2b is equal to negative 3b plus 6. We'll get our b's on the same side, so that gives us b is equal to negative 2. Now, when you solve logarithms, through the process of solving, we had to remove the log, and which means we temporarily remove some restrictions. So before I call b as my final answer, I got to do a quick spot check and make sure that if I put this number in where the b's are, it doesn't make me apply the logarithm to 0 or a negative number. Put negative 2 in, that turns out to 8 plus 4. Put negative 2 in, that makes 6 plus 6, so we're all good here. There's my answer. Okay, next problem here. So log base 18 of x squared minus 1 equals log base 18 of negative 6x plus 1. We got a similar thing where log base 18 is applied to my whole left, log base 18 is applied to my whole right-hand side. So I really can just set the insides equal and go try to solve for x here. And so I'm looking at what we have here. Let's get our x's on the same side. We got x squared plus 6x. Move the 1 to the right-hand side equals 0. Take out the greatest common factor, the left, which is x. And we get two possibilities for x. I can get x is equal to 0, and I get x is equal to negative 6. Now I do a spot check here, make sure that these aren't extraneous solutions. So if I put in 0 for x, and to the left side, I get 0 squared minus 1. That's a negative number inside of the log. I can't do that. And so x is 0 is not a possible solution for me. Now I go put negative 6 in and do the same thing. Negative 6 squared minus 1 is bigger than 0. Negative 6 times negative 6 minus 1 is bigger than 0. So my answer here turned out to only be negative 6. Next one here. So this time I don't have logarithms applied to both sides. There's only one log in my equation. So the technique to solve this one, or the process anyway, is to isolate your logarithm. So I need to move this 2 to the other side and then divide by negative 2. And after I do that, I have log base 4 of negative 3n minus 8 is going to be equal to, what is that, positive 3. So from here, what I do is, in order to solve this, I have to write this without having a logarithm on the left-hand side. So I got to write as this exponential inverse. So I take the base of the log, I'm going to raise it to this power, so it'd be 4 to the third, and set it equal to what's on the inside. So I'd have 4 to the third power is equal to negative 3n minus 8. Well, 4 to the third is 64. And then we would go from there. So I'd add the 8 to the other side. That's 72. Divide by negative 3. And we get negative 26. I don't box this answer in because I want to make sure that negative 26 doesn't make the inside of the log 0 or negative. Negative 26 times negative 3. Then minus 8. That is definitely going to be bigger than 0. So there's my answer. New problem here. So this one, we have actually 3 log base 8s in our problem. Now, in order to do this problem, I need to make it so that way the left-hand side only has 1 log base 8 instead of 2. So we're actually going to condense this. So I have 2 logs adding. So I can condense the left-hand side into log base 8 of the product of the inside. So it'd be I'd have 9 minus 15x equals log base 8 of 14. Now it becomes a problem very similar to what we did earlier, where the log base 8's on my entire left, log base 8's of my entire right. I can set the insides equal, and I can go solve for x. So 9 minus 15x is equal to 14, and then we go solve from there. So that's negative 5 is equal to 15x. 1/3 negative would be x. And I do a quick check. I want to make sure that it's not going to make the inside of the log that has the x 0 or negative. If I put in negative 1/3 here times negative 5 and then put it with the 3, inside bigger than 0, so there's my answer. All right, another one here. So this time I have 2 logs, but they're on the same side. So in order to solve a logarithmic expression where you have multiple logs, you got to condense them in order to solve. And so I'm going to condense this because I'm adding the 2 log base 6's on the left. I'm going to condense it to the product of the inside. So it'd be log base 6 of 81 minus 27x squared is equal to 1. Now I go to solve. Now I do not set the inside of the log equal to 1 here because there's no log written on the right hand side. What I would do is I take the base of this log on the left. So 6, I'm going to write this log as this exponential inverse. It would be 6 to the 1 power equals the inside. And so we'd have 6 to the 1 is equal to 81 minus 27x squared. And then we'd go solve for x. So we'd have, what, 27x squared is equal to 75. Divide by 27. And you get x squared is equal to 25 over 9. So we'd continue through the process of solving. Now don't forget, I'd have to take the square root of both sides here. The square root of x squared is the absolute value of x. And the square root of 25/9 is the square root of 25 divided by the square root of 9, which makes 5 over 3. So we have 2 possible answers for x. X could equal 5 over 3, or x could equal negative 5 over 3. And now I have to check and make sure that if I put those numbers in, it doesn't make me take a logarithm of a value equal or less than to 0. So if I put 5 over 3 in here, square 5 over 3 is 25 over 9 times 3 is 25 over 3. And I need to take that away from 9. Well, 25 thirds is smaller than 9 thirds, so it keeps the inside bigger than 0. So both of these are going to be my answer. All right, new problem here. So I have log base 3x plus 3 minus log base 3x plus 2 is equal to 3. In order to solve, I have 2 logs on the left. I got to condense. I am subtracting logarithms. So our properties of logs tell us that if you're subtracting 2 logs with the same base, condense it into division. So it would be log base 3x plus 3 over x plus 2. All that's inside of that log is equal to 3. Now to solve, I have to write as the exponential inverse, so base of the log, 3, to this as its exponent power, so it'd be 3 to the third equals what's on the inside. So 3 to the third equals x plus 3 over x plus 2. 3 to the third is 27. And then we'd solve from here. I got to multiply to get the x plus 2 out of the denominator. All right, and so we do that, we'd have 27x plus 54 is equal to x plus 3. And then we would finish solving from there. So I get my x's on the same side. So 26x equal to negative 51. Divide by 26. And we have this here. So negative 51 over 26. I don't box that thing in yet. I want to look and make sure that I can use it. So negative 51 over 26 plus 3. Well, that negative 51 over 26 is smaller than negative 3. Or actually, it's 51 over 26 is smaller than 3. So this is going to be bigger than 0. And it's actually just barely smaller than 2. So it's going to keep that bigger than 0. So this is our answer. All right, this one here, we want to solve for x, and we actually do not have any logarithms. Now we want to find the exact value of this. And so the process of doing this is we are going to isolate the base 11. So I need to subtract by 5 and divide by negative 4. If we do that, we're going to get 11 to the 9 minus 6x power is equal to 15 over 4. Now, when you get to here, you stop for a minute. And because I have base 11, and I want to make sure that this side is not a negative number, because if it was negative, I would stop and say no solution, because we know that we can't make a positive 11 base become 0 or negative just by changing its exponent. So we do that spot check. Now, this is bigger than 0, so I keep going. to keep going from here, we want to take a log with an appropriate base. Now, you could take the ln of both sides and then go to work, but I want to use a much cleaner way, which would be to use a log base 11. So I could say log base 11. Now, why did I pick 11? Because that's the base that has the exponent in it that I want to solve for. So log base 11 of 15 over 4 is equal to the exponent, which is 9 minus 6x. And then we would go solve from there. So I kind of rearranged my terms a little bit. I'd have 6x is equal to 9 minus log base 11 of 15 over 4. And then we would divide by 6. And so the exact answer here would be 9 minus log base 11 of 15 over 4 divided by 6. So that's the exact answer. Okay, last one. This is actually kind of a tricky one. We have 3 to the x minus 1 power is equal to 2 to the 2 minus x power, and I want to solve. Now, I cannot just set the exponents equal and solve this because I have two different bases. You have a base 3 on the left and a base 2 on the right. So we actually have to work here by getting the x out of the exponents since I can't use properties of exponents. What we would do is we're going to apply the natural log to both sides. So I'd have the ln of 3 to the x minus 1 power is equal to the natural log of 2 to the 2 minus x power. Properties of exponents, properties of logarithms tell me that I can take the exponents and inside of the log and make them coefficients. So the left side becomes x minus 1 times the ln of 3. The right side becomes 2 minus x times the natural log of 2. Now, to solve for x, I got to get my x's isolated on the same side. The only way I can really do that right now is to distribute the ln of 3. So I'd have x times the ln of 3 minus the ln of 3 is equal to, we'd have 2 times the ln of 2 minus x times the ln of 2. Now we'll get our x's on the same side. So we'd have x ln of 3 plus x times ln of 2 equals, I'm going to move the ln of 3 to the right-hand side, so it'd be 2 ln of 2 plus the ln of 3. Now, what we're going to do is we're going to factor out an x on the left-hand side. So we'd have x times the ln of 3 plus the ln of 2 equals 2 times the ln of 2 plus the ln of 3. Now we were going to divide so that way we can get x equals. So I have x equals, we'd have 2 ln of 2 plus the ln of 3 divided by the ln of 3 plus the ln of 2. Now, you might be thinking right now, wait a minute, can't I use properties of logarithms on this right-hand side and clean this up? And you absolutely can. See, what I can do is I could take that 2 and make it the exponent inside of that ln. So I'd really have the ln of 4 plus the ln of 3 divided by the ln of 3 plus the ln of 2. And we have another property of logarithms we can use. If you're adding logs with the same basis, you can times their inside. So that's going to become the ln of 12 over the natural log of 6. And we could look at this one step farther and be like, well, wait a minute. We have done something like this before where we have the same base of a logarithm dividing, and that is the change of base formula. See, the change of base formula says that if you have log base A of B, and I wanted to rewrite that in terms of natural logs, I'd have the ln of what's on the inside divided by the ln of the base. Well, what we're doing is we're actually going to work in reverse here. So if I look, what I'm dividing by inside of that ln is actually the base of the log. So I'd have log base 6 of, and then what goes on the inside of that is what's on the inside of the ln that's on the top. So it'd be log base 6 of 12.